Hello guys, today we are starting with change of basis. Change of basis under linear algebra, but particularly is under a matrix. Matrix, or we call it linear dependence. So there is correlation between linear dependence and change of basis. But basically, today we are talking about change of basis. Now, let's S. So this is the concept of change of basis before we launch into calculation. So let S U1, U2 to Un be a basis of vector space V, which means U1 is a basis, U2 to Un, they are bases in S. So, and S prime, the S prime is just indicating S prime can be anything. So, but S prime is also having bases V1, V2 to Vn, be new bases. It means there are new bases here as well. V1 is new base, V2 is new base, V3 to Vn, be new bases. Now, if A11, A12 to A1n are scalar, it means they are all scalars. Are scalars? It means scalar means ordinary number, they are not vector. Then each vectors in the new basis, that is individual vector, that is V1, V2 to Vn, in the new basis can be written as a linear combination of vector S, which means we can write the basis of S prime as a linear combination of the basis of vector S. That is, and according to the concept of linear combination, V1 equal to A11 U1, that is scalar vector, A1 to U2 scalar and vector, plus A1 and Un, which means to the last one. And this statement is a linear combination. It means we have written the vector V1 in S prime, which means that vector V1 is a basis as a linear combination of the basis of S. And the same thing applies here. V2 equal to A21 U1 plus A22 U2 plus to A2n Un, which means we have written vector V2, which is the basis V2, as a linear combination of the basis of S, as you can see. Then to Vn is the last basis of S prime, which is Vn, which means we can write it to the end. This does mean to Vn, which is the basis of S prime, as the linear combination of the what? Basis S. So all these things are just concepts. So after solving the example, we will understand the concept of all these explanation. Now, where all A's are constants, note, constant means scalar, or we can call them scalar. So they are all scalar. All A's, that is A11, A12, all A's, they are all scalars. Now, let P be the transpose of the above matrix coefficients, where P will be the transpose of everything we have generated from the linear combination. So the P will now be the transpose of what we have gotten. So the P is the transpose of the above matrix coefficients. Then P will now be in form of Pij. Pij means P in form of matrix. So this P that so it means this P, which is the transpose of what we have gotten here, is called the change of basis matrix. We call it change of basis matrix. So all these things are just explanation of the concept here. So after solving an example, you will get it better. So let's dive into question. Now, the question 1, it says, consider the following two bases in R2. R2 means we call it n tuples of vector, which means the vector has two inputs, 1 and 2, 3 and 5. That's the essence of R2. So the question says, consider the following two bases in R2, which means S equal to, note, this basis means plural of basis, IS. the plural of the is es. So we now say let this s be 1 comma 2. Note this is representing u1, which is the basis, one basis of s. 3 comma 5, this is representing u2, which is the second basis of s. And s prime, which is the new basis, or we call it second basis, is what? 1 comma minus 1 comma what? 1 comma minus 2. Note, we can call this v1, which is the basis in s prime, and this is what? v2, which is the basis in s prime. The question now says, find the change of basis of matrix. Find the change of basis matrix P. Which means if you find the change of basis matrix P, don't forget that I said P is called what? Change of basis matrix. Now our aim is to find the change of basis matrix P from S to the new basis S prime, which means from S, you want to change the basis of S to S prime, which means the concept means, please note, from S to S prime. From S means we want to change all the bases of S to the new basis S prime, which means the to means we want to write the basis of S prime as a linear combination of the basis of S. That is the concept there, which means we want to write the what? We want to write the basis of S prime, because we are changing it to S prime. To, note, not the word, from to, which means we are changing all the bases of S prime, or we want to write all the bases of S rather. We want to write all the bases of S as a linear combination of bases of S prime. That's the meaning of to S prime. Now, how can we solve this? Let's go. Let's solve the example 1. Solution. We are given that S is what? We are given that S is 1 comma 2, and we are given that the other one is 3 comma 5. So from here, and we are given that S prime is what? S prime is 1 comma minus 1, and the other one is what? 1 comma minus 2. Okay, please don't forget the question. Changing the basis from S to new basis S prime, which means we want to write the basis of S prime. The basis of S prime as a linear combination of the basis of S. So now, from here now, I will now say, let's say this one is U1, this one is U2. Let's say this one is V1, this one is what? V2. Which means V1 will be equal to, don't forget that we use A in the concept. It can be X, since it's a constant, scalar. X U1 plus Y U2, which means we have written the basis V1 in S prime as a linear combination of the basis of S, because we are changing it to S prime. And at the same time, it will be what? V2, which is this, equal to what? S what? U1 plus what? Because we can say this is X1, X2. This is Y1. You can say this is Y2. Y2, U what? U2. Which means we have also written V2, which is basis of S prime, as a linear combination of the basis of S. So from here, I can now continue my solving. What is my V1? So I want to solve the first part. V1 is what? 1 comma minus 1 is equal to X1 bracket, what is U1? 1 comma 2 plus Y1 bracket, what is U2? 3 comma 5. But we have to solve it in form of what? In form of column matrix. So it will now be, this can be written as 1 minus 1 as a column matrix. This is row. We want to change it to column, equal to x1 bracket 1 and 2 plus what? y1 bracket what? 3 and 5. As you can see from here, we can open the brackets, that is 1 and minus 1, we close it, equal to x1 times 1, x1, x1 times 2, 2x1. We close it, plus y1 times 3, 3y1, y1 times 5, 5y1. We close it. So we can add this together, which means we can say x1 plus 3y1. So now give us x1 plus 3y1 by relating it equal to what? 1. Equation 1. By relating this now, we can say 2x1 plus what? 5y1 equal to what? What is here? Minus 1. x1 plus 3y1 equal to 1, and 2x1 plus 5y1 equal to what? Minus 1. Now we move to the next part. Now from here we solve it simultaneously. By solving it simultaneously, we can use elimination method. I want to eliminate x. This is equation 1. This is equation 2. So I can multiply equation 1 by 2 so that it can be 2x1. So it's now be times 2 so that it can be 2x1. 2 times 2x1, we have 2x1. 2 times 3y1, we have plus what? 3y1. 2 times 1, so we have 6y1. 2 times 3 equal to 2 times 1, we have 2. Then we got this back, 2x1 for the equation 2 plus 5y1 equal to what? Minus 1. So we want to solve it simultaneously. I want to eliminate x1. So it will be this minus this, 0. 6y1 minus 5y1, that's what? y1 equal to 2. Please don't forget, the minus will affect everything. 2 minus minus 1, that is what? 3. 2 minus minus 1, minus times minus plus, it will become 3. So my y1 is what? Is 3. Now substitute y1 into equation, I can say 1, which is this. 2 what? 2x1 plus 6. What is my y1? 3. Equal to what? Equal to 2. So 2x1 plus 18 equal to what? Equal to 2. So 2x1 will now be equal to what? Will now be equal to 18, 2 minus 18. 2x1 will now be equal to minus 16. But don't forget, we are looking for x. Divide both sides by what? By 2. So x1 will now be minus 16 over 2, which is equal to minus 8. So have we gotten minus 8 here as our x1, which means, therefore, we can now say that v1, don't forget we are coming from here. Don't forget we are coming from here, v1. v1 equal to, what is my x1? Minus 8 u1. Since I've gotten my x1 as minus 8, substitute, plus y1. What is my y1? y1 is what? 3. 3 what? u2. This is my v1, part 1, which means I've written the basis v1 as a linear combination of the bases of s. Now, for the second one, I'm just through with this, remaining v2. So I'm using this now. For v2, I'm using this. That is 1 comma minus 2. Now, going to what? Going to the next part, which is v2 equal to, now, okay, let me use this part. Let me continue my solving here. Okay, since we have gotten our V1 as a linear combination of the what? Of the basis of what? S1. Sorry, since we have gotten our V1 as a linear combination of the basis of S, which is this. Now, we can now move to V2. We want to write V2 as a linear combination of the basis of S. So, which means V2 is this, and our U1 is this, and our what? U2 is what? Is this, from the given question. So, now, we have to make it to be in form of colon matrix. 1 minus 2 equal to x2 bracket 1, 2 plus y2 bracket what? 3 and what? 3 and 5. Now from here, what will happen is that the same approach, I will distribute this x2 and y2 into it. It will now be 1 and what? Minus 2 equal to x2 times 1, x2, x2 times 2, 2x2, close it, plus y2 times 3, 3y2, y2 times 5, 5y2. I close it. Now from here, I will now add it together, which means the x2 plus 3y2, s what? S2 plus what? 3y2 equal to what? What is here? 1. Equation 1. That is, we are getting another simultaneous equation. Then what again? 2 what? 2x2 plus what? 5y2 equal to what is here? Minus 2. Equation 2. Now from here, I want to eliminate x2 to get y2. I can say equation 1 times what? Times 2. 2 times x2, that's what? 2x2. 2 times 3 plus what? 6y2 equal to 2 times 1, 2. And this one is what? 2 what? 2x2 plus what? 5y2 equal what? Equal to minus 2. So I want to eliminate x2. 2x2 minus 2x2, 0. 6y2 minus 5y2. That is what? Y2 equal to 2 minus, don't forget, the minus will affect everything. 2 minus minus 2. That is what? 4. Since 2 minus minus 2, minus times minus plus, 2 plus 2, 4. So which means in conclusion, our y2 is equal to what? 4. Y2 is equal to 4. Now substitute y2 into equation 1 so that we can get our what? We can use this or this, anyone, so that we can get our what? X2. Now we substitute. By substituting, it will become what? So by substituting, it will now be, I'm using this. I can use this. In fact, I can use anyone to generate my x2. So it will now be what? X2 plus 3y2 equal to 1. So since my y is what? 4, substitute 4 into it. It will now be x2 plus 3 bracket 4 equal to what? 1. Now from here, it will be what? X2 plus what? 12. 3 times 4, 12 equal to 1. So x2 will now be what? 1 minus 12. So x2 equal to minus 11. Which means I've gotten my x2 as what? Minus 11. Which means, please don't forget, we want to write this as a linear combination. Which means since I've gotten my x2, therefore x2 equals to what? My x2 is what? Minus 11, and my y2 is what? 4. So V2, making reference to this, will now be x2. What's my x2? Minus 11 u1, as you can see here, plus, what is my y2? 4. 4 what? u2. But I've not gotten my final answer. Now, recall. We have to recall. Recall that, we've gotten our V1 already. That V1 is what? Minus 8u1 plus what? 3u2. And we've gotten our V2 here as what? Minus 11u1 plus what? 4u2. which means V2, don't forget V1 will come before V2. So V2 will now be what? Minus 11U1 plus what? 4U2. But you can't stop here because you've not gotten your final answer. My final answer, the question says, write change of basis matrix P. That P is the change of basis matrix, and it is the transpose of whatever we have gotten here. Transpose means write all the row in column, which means, you know, this is minus 8 and plus 3. Instead of it will be like this in form of matrix, it will be in form of column. Please go and look at the concept that I said P is what? The transpose of whatever I've gotten here. Which means instead of writing minus 8 plus 3 like this, it will be in vertical. It will now be minus 8 and what? 3. Minus 8, 3. Why this one will now be what? Minus 11 and what? And 4. This is the final answer, which means this P is the change of basis matrix. That is the final answer for this. So if you stop here, you are not correct. You have to write it in change of, because the question says write it in form of change of basis matrix P, which means all the row becomes column for the final answer. Thank you very much for watching.